Smartphone-based operator control unit for military robots. This video is based on my 2014 DuPont Challenge essay. As a soldier clambers across a muddy battlefield to survey his opponents, he deploys a 100-pound robot from his backpack and maneuvers it with a large laptop attached to his belt. A fireman, fatigued from lugging a robot up 36 flights of stairs, collapses in front of the very victim he is supposed to rescue. Situations like these were nearly unavoidable many years ago, but most of these robots have now been replaced by palm-sized platforms that have the same, if not additional, capabilities. Replacing the bulky, power-consuming laptop-based operator control unit with a portable, low-power smartphone will help soldiers and first responders further improve maneuverability in the field and give them an edge over their opponents. Since World War II, military robots have aided soldiers and first responders in completing their missions from a safe standoff distance. Until recently, most of these robots weighed more than 100 pounds and were controlled by large, militarized laptops. Now, soldiers are able to use miniature robots to complete the same tasks, but these robots are still controlled by large laptops, burdening the very individual they were supposed to aid. Recent research and development efforts have resulted in robots that weigh less than 5 pounds and have the same capabilities as their larger counterparts. However, projects that have sought aggressive miniaturization of field-ready platforms have resulted in systems controlled by bulky operator control units, thereby defeating the purpose of a compact robot. Engineers across the country have enjoyed phenomenal success in developing smartphone applications to control small robots, eliminating the need for a large, power-hungry, militarized laptop. Smartphone-based OCUs significantly reduce a user's weight, and many soldiers and first responders already utilize smartphones in other aspects of their jobs. As a result, a smartphone-based OCU significantly reduces a user's load and is a cost-effective replacement of a traditional laptop-based OCU. Nicholas Fung outlines the challenges of creating a compact robot. He claims that the robot needs to carry additional hardware to communicate with the smartphone-based operator control unit, which thereby increases its size. Some of the robot's electronics include a 9-volt battery, a Bluetooth module, a camera, and a microcontroller board, all of which need to fit inside the small form factor of the robot. Moreover, Fung is able to effectively convey the need for a novel OCU by including some of the many features of a smartphone-based operator control unit. In this screenshot, we can see that the smartphone application displays a video feed, has command and control capability, and can collect sensor data from the robot. Through extensive trial and error, Fung concludes that an Android-based OCU has a smaller, more compact form factor and performs nearly the same functions as a laptop-based OCU. Fung also determines that the smartphone's small form factor allows it to be controlled by only one hand, leaving the other hand available to perform other tasks. Fung's study laid a precedent for future studies and emphasized the need for additional research and development in the nascent field. He laid the groundwork for engineers to develop a smartphone-based OCU to control miniature robots. Rafael Aroca, Antonio de Oliveira, and Luis Gonçalves were one of the first researchers in the world to actually tackle the challenge of developing a smartphone-based OCU. In doing so, they were able to analyze some of the benefits and drawbacks to their initial prototype. The authors experimented with many new capabilities of smartphones and attempted to utilize some of the many accessories that could be beneficial for robots, such as a temperature sensor, humidity sensor, and light sensor. Additionally, Amber Walker, David Miller, and Chen Ling researched the benefits of a smartphone-controlled robot. In their study, they reported the increased intuitiveness of a smartphone application. Users do not need a tutorial to control the robot, and gesture input methods allow soldiers who have no prior experience with smartphones to control a robot. Furthermore, their study revealed a number of questions such as voice control, screen glare, ruggedization, and battery life of the smartphone-based operator control unit. As concluded by the various researchers, a smartphone-based OCU offers a touch-based environment for users, which significantly reduces the learning curve for controlling the robot. However, Amber Walker and her colleagues also stated that touchscreen devices are not ideal in all field conditions because of the difficulty in operating a device when hands are dirty or have gloves on them. Amber Walker stated in personal email communication that while not as robust as some of the other control interfaces currently used in the field, smartphone-based OCUs provide a reasonable, intuitive option, especially for novice users. However, the attention demands of virtual buttons are a large drawback for potential users. Nicholas Fung examines potential benefits and drawbacks to a smartphone-based OCU. He states that 2011 smartphones do not have as much capability as laptops, and, as a result, the smartphones may restrict the user to certain uses of the platform. He also adds that smartphones are not as robust as laptops, which means that they will often get damaged in the field. Additionally, Amber Walker and her colleagues determined that a user is unable to control a touchscreen device when his or her hands are dirty or have gloves on them. In conclusion, although a smartphone is not as rugged or capable as a laptop-based OCU, they are still superior to them for use in the battlefield. The smartphones significantly lighten the load of your soldier or first responder, and this enables them to carry additional life-saving devices. By enabling robots to be controlled by smartphone-based operator control units, engineers will reduce much of the weight that soldiers and first responders need to carry while allowing them to complete their missions more effectively. Scientists across the world have conducted invaluable research that will make these technologies available in the coming years. In the future, smartphones will control swarms of robots, and mobile applications will be tailored to an individual's preferences. The cutting-edge research and development in this field will have a positive impact on the mission outcomes of soldiers and first responders. I would like to thank Dr. Amber Walker for helping me complete this project.